Good day, everybody. This is our first lecture on the muscular system. Currently in lab, you're trying to learn how to identify, you're learning the names of several muscles. You'll have to learn the names of what they do and their origins and insertions and basically types of muscles they are. This particular lesson, we're going to be talking about the different forms of movement as well as ways to identify those muscles. Now, in different body movements here, the two we're going to investigate on this one here are in opposite of each other. One is called flexion, which is the decreasing of a joint angle, and that's going to be generally along a sagittal plane. So if you look at my pictures here, flexion of the shoulder, you're moving your arm up in this general direction. Flexion of your knee, you're going to be bending it backwards as you're trying to raise your heel out towards your gluteus maximus. Now, extension is just the opposite. That's going to be increasing the joint angle, and again, that'll be in a sagittal plane. Now, extension, if you look at my picture here, when you're straining your leg out, knee extension. But you can also have in your head hyperextension, where you tip your head way back like you're looking at the clouds, flexion, looking down at your shoes, and extension is raising your head up. Now, rotation, like you see in this picture here, is any kind of movement of a bone along the longitudinal axis. So if you look at my picture up here, moving your head from left to right, rotating around your vertebral column, that is rotation. But you can also have rotation around your legs. Lateral rotation would be turning your toes out. Medial rotation, turning your toes in, kind of like going pigeon-toed. Now, that will not be true on the arm. That's a special type of movement there, which we'll look at later. Now, this slide here, we're going to be looking at three kinds of movement here: abduction, adduction, and circumduction. If you look at my picture over here, abduction, that's the abduction, abduction, is you're going to move your hand away from the midline. This would be like doing a jumping jack when you kind of raise your hands to the side above your head. And the opposite of that is adduction, bringing your hands to the side. So a complete jumping jack would involve both movements of abduction and adduction. Even though we're showing it here only in the arm, the legs will also move by abduction and adduction. So on a jumping jack, your legs and arms will both abduct, and at the end of the jumping jack, when they come back together, that would be adduction. Now, this slide is also showing a movement called circumduction. Circumduction is where the proximal end of the bone, in this case the shoulder joint right up here, the proximal end of the shoulder stays stationary while the distal end goes around in a circle. Circumduction. This would be kind of like, any kind of movement like this would be in a ball and socket type joint. It's going to involve components of flexion, extension, abduction, and adduction. It's going to be a combination of all of those we've talked about so far. Now, a special type of movement that you see only in your hand is opposition. This is unique to humans and other great apes. This is the ability to touch our thumb to all of our toes. Having an opposable thumb enables us to do things like grip screwdrivers, doorknobs, things like that. A good handshake, any kind of a good grasp. Now, in your forearm, you have a special type of way of movement here where you can move your palm up or palm down. These are our supination and pronation. Supination is where you take an anatomical position. Whereas we described the anatomical position before, your palms are forward or your thumbs are facing out laterally. I always tell my students, think about this. In supination, you will hold a cup of soup in your hands. While pronation is the opposite. Your thumb is going to go medial and your palm will be pointing back. And again, this is a movement found in the forearm because of the way the arrangement of the radius and the ulna are. Those bones will cross over each other during this special type of movement. Your ankles, you have two types of movement, inversion and eversion. Inversion is generally the way that you will sprain an ankle. It's where you turn your sole of your foot towards the midline or medially. Just think about it. Anytime you might have twisted an ankle, that's probably been an inversion type of injury. Less likely to ever occur, maybe that would occur if you were playing basketball and coming down on somebody's foot, would be eversion of the ankle, where the soles turn laterally. It doesn't happen very often, but occasionally you may sprain your ankle this way too, because your foot will not go quite as far this way. On the foot, we also have dorsiflexion, which would occur if you pull your toes upward, like you're staying on your heels. In this three-part picture, you see the top one up here, this would be dorsiflexion, where the person's stepping down. So every time you take a step forward, your ankle goes into dorsiflexion. You're going to land on your heel first. Then as you go forward, get that little spring off your foot, you'll go plantar flexion. This would be standing or pointing on your toes, or even taking as a step. As you shift your weight forward, taking your step, your toe will push down against the ground. So in a general step, you'll go from dorsiflexion and then slowly move towards plantar flexion as you take your step off. Now your goal in lab is to learn the names of about 30 muscles and their actions and everything. And all 30 of these muscles that you're going to be working with can be grouped into more than 4 groups, but we're going to work only with 4 major types of muscles. I call the first group here the prime movers. These are the muscles that have the major responsibility for a certain action. So for example, if you were doing straightening your arm out, as you study your lab here, the tricep muscle is the one that's going to be working to extend your arm or straighten your elbow. That would be a prime mover. Or pulling along in your bicep, doing a curl, the biceps would be a prime mover. Now with every prime mover, the prime movers are going to be found on one side of the joint, and the antagonist will be found on the opposite side of the joint. The antagonist is the muscle that opposes the prime mover. So just doing a simple bicep curl, with a dumbbell, you'll see both examples. As you perform the curl, as you flex your elbow, the biceps and the brachialis muscles are moving that arm. The antagonist is the tricep, and it's basically relaxing during this time. But if you were trying to straighten your arm out, then the biceps will become relaxed, and the triceps will become the prime mover. Now some muscles actually assist the movement of the prime mover. Those are called synergists. Not all muscles are going to work at the same angle. That's why we have over 600 muscles making up our bodies. So some of them have dual functions. The synergist, depending on the angle of action, is going to help the prime mover, complete the action. And still, we have a fourth group, at least we're going to use in our class, called the fixator muscles. These are muscles that are going to stabilize the prime mover here so that it's not going to be wiggling all over the place and prevents unwanted motions. Now in lab, you're going to be focusing on trying to learn the names of these muscles, and some of the muscles are going to have very unusual names, to say the least. But here are a few ways that might help you to think about these muscles and their names. Some muscles are named, by the way the direction fibers run. For example, by now you've probably in lab worked with the rectus abdominis. The word rectus means that the fibers are straight. That's what rectus means, straight. Okay, you'll see other descriptions. You'll also find the relative size of the muscle in some of these names. For example, maximus would be large, minimus, small. So when you think about gluteus maximus, that's the big gluteus muscle. Gluteus minimus, small butt muscle. Some muscles are named by the location. Where do you find it? For example, what bone is it under? So as you're studying the skull, there's a muscle called the temporalis, which helps to close your jaw. You have the biceps femoris. That muscle is found on the femur muscle. Tibialis anterior. It's found on the tibia. And some are named by the number of origins. The two most notable examples that you probably know by now, you have the biceps. Bi is a prefix which means two. Sep means head. So bicep, two heads, two origins. So tricep would be three heads or three origins. Now sometimes muscles are named by their origin and insertion. Now, an origin is the point of attachment that is the least movable point. Okay, so again, if you were doing a bicep curl, the bicep muscle, the two heads are located on the upper part of the arm, on the shoulder, and the insertion is going to be the most movable part, where it's going to go down, all the way down, attached to the radius. Now, if you look at those points on the shoulder and on the radius during a bicep curl, the points on the shoulder are not movable, or they move very, very little. Those would be the origins. The insertion will be on the radius. That's the part that moves the most. In old textbooks, they used to say the origin does not move at all, but in actuality, it does move a little bit. The insertion is by far the most movable portion. Some muscles are named for their shape. For example, deltoid muscle in your shoulder. That's triangular. Then you got the rhomboid muscles in your back and the trapezius muscles, all based on geometric shapes. Finally, some muscles can be named by the action. For example, flexors and extensors. And in our class, we're not going to worry about naming all the little muscles that spin and straighten your fingers and everything. We're going to simply call those flexors if they're found on the front part of your forearm, to flex your wrist and your fingers, and extensors if they're found on the back side of your hand from anatomical position. Back side of your hand, which will straighten your fingers or extend or straighten and hyperextend the wrist. Hope these little hints will help you as you work through learning the names of these muscles. Thank you.